We're ready to start our rational expressions and rational equations chapter. This is definitely our toughest chapter. It's very quick, only 6 sections, but it is mean. First 2 sections are pretty easy, but starting with 5-3, you really need to dig in and work hard. So, what is a rational expression? A rational expression is just a fraction. But it's not your typical fraction. Now we're going to have polynomial expressions in our fractions, so that's why they're just not called fractions. They're called rational expressions. So still contain a fraction, but with polynomials in the numerator and the denominator. So that's what this little thing is trying to tell us here. So a rational function can be written in the form p of x over q of x. Both p and q are polynomials, and remember, just like any other fraction, the denominator can never equal 0. That's going to play a big part in this first section, as we're going to figure out values that make the denominator 0 so we can throw them out. We call those excluded values. So first off, we're just going to practice evaluating functions, which you've been doing for quite some time. So we learned that this means take the function f, everywhere you see an x, replace it with -1. So this says the function f evaluated at -1 is equal to what? So we put -1 in everywhere we see an x, -1 minus 4, and we get 2 over -5. And generally, like we learned earlier, Alex likes the negatives in the numerator. Your calculator likes the negatives in the numerator. This is the typical way to write it, not this way. So we just replace the x's with -1, and the function value, or y, is -2/5. Okay, so why don't you go ahead and try the next two? This is easy stuff. So go ahead and turn off your camera and try the next two and see how you do. Okay, so f of 0 would be 0 plus 3 over 0 minus 4, which is 3 over -4, which is better written as -3/4. Nice, right? We like this. If it could stay like this, we'd be real happy. Okay, f of 4 means evaluate the function at x equals 4. So 4 plus 3 over 4 minus 4. 7 over 0. So do we just leave that? What did we learn to write for that? If you don't remember, let your calculator tell you. 7 divided by 0 is error. 7 fraction bar 0. Whoops. 7 fraction bar 0, because I know some of you are like, I never know when to use which one. Well, they give you the same answer. It doesn't matter. We do not know how to divide by 0. So because we don't know how to do it, we call that undefined. So we're going to learn later that that means 4 is an excluded value of the domain. X cannot equal 4 because it makes the function undefined. So we're going to call that an excluded value. We have to throw it out because it makes the function undefined. And if you remember right from your slope chapter, we're never allowed to leave 0 in a fraction for our final answer. So anytime you see 0, numerator or denominator, it can always be simplified. To find the domain of a rational function, we first set the denominator equal to 0, because that means what will make my denominator 0? Well, whatever makes it 0, I need to throw out. It's an excluded value. and then we write the domain using set builder notation and throw out those excluded values. So let's look at this example. This is a great example. In fact, it's number 1 on your test. And you'll see it's also number 1 on your practice test. And it's also on the final. Lots of domain questions on the final. There's domain of a radical, domain of a rational, domain of a log, domain of a parabola. Yeah, there's 4 or 5 domain questions on the test. It's a heavy subject in your next class, so we try to cover it as much as possible. So to find the domain, according to the directions above, first we set the denominator equal to 0. So x squared minus x minus 42 equals 0. And remember how I said every problem you do in Chapter 5 is going to involve factoring? Well, look at that. Factoring. So that's why I stressed it so hard in Chapter 4, because you're going to factor like there's no tomorrow in this chapter. So x squared, and we learned that the middle term, if it doesn't have a number, to put a 1 there, because remember, we don't want to say factors of 42 that subtract to x. There aren't any numbers that subtract to x. It's factors of 42 that subtract to 1. And that would be 6 and 7. This says the signs will be different. And this says make sure you make the larger number negative. So then, because it's a double bubble, because the leading coefficient is 1, I can go straight to my parentheses, x minus 7, x plus 6. And then we learned if a times b equals 0, either a is 0 or b is 0. And when we solve, we get 7 or negative 6. So those are called our excluded values. And why are they excluded? Because we just learned they are the values that make our denominator 0. Anything that makes our denominator 0 is undefined. So we call those excluded values. We have to throw those out of our domain. So this is how you would write using set builder notation. Remember, a lot of you missed that on your first test, so this is important to take note of this. X, such that x is a real number, x cannot equal negative 6, or x cannot equal 7. X cannot equal negative 6, x cannot equal 7. So these are excluded values. Why? Because they make the denominator 0. Anything that makes the denominator 0 has to be thrown out of the domain. That means when we solve, we can't get them for answers because they make my denominator 0. So then we're asked to write an interval notation. And remember how Alex sometimes has you do this before the graph? Well, just jump over here and do the graph first. Then write your interval, because your interval notation comes from your graph. So if Alex asks you to do it, to write this first, well, just on your own paper, do your graph first, then write that. So these little open circles mean don't include negative 6, don't include 7, because they make my denominator undefined when I include them. So everything else on the number line works except those 2 values. So now we have to use interval notation to show that those 2 values don't work, but everything else does. So remember how I said when you do interval notation, you keep it in the exact same order as the number line. So my first interval should be negative infinity to negative 6. There it is. Notice infinities always get parentheses, as we learned in the first chapter. Negative 6 has to get a parenthesis because we can't include negative 6. When you use a bracket, that includes negative 6. And it's an excluded value. I call it, well, some books call it an undefined value. Our second interval, and remember when we have more than one interval, we have to use the little union symbol, is parentheses negative 6, comma 7. And again, both parentheses because they're excluded values, so we can't include them. United with our third interval is 7 to infinity. So order matters. Anything out of this order would be wrong. Shape of the parentheses matter. So everything you see has to be written exactly like you see it. You can't leave the U's off. Everything has to stay the same. That's why we graph first and then do that. I actually put a number line on my paper pencil test so students would graph and then do this. So exact same order as the number line. And I noticed when I was looking at your test from the first chapter, a lot of you got the order wrong, and that was because you didn't draw the number line first. So be careful with that. And we have, I think, 6 of them to practice on the next page. So let's go ahead and look at those. Okay, so find the domain of the following functions. So we're going to do the number line, we're going to do the interval notation, and we're going to do the set builder notation so that we're all set. And remember, Alex may not do this order, but this would be the best order you can do if you want to use the number line to give you your interval notation, which is easiest. Okay, so on page 1, it says to find the domain of a rational function, you set the denominator equal to 0 because that's what can't be 0. So I say x squared minus 4 equals 0. Well, this is where chapter 4 comes at you. I have a quadratic set equal to 0, and we learned in chapter 4 that means you need to factor the left side. So 2 terms can only be GCF, squares, or cubes. No GCF. Are they squares? Yes, they are. So this says the signs will be different. So set up 2 parentheses. And if you remember right, this is the one where we do square roots. So we do x plus, x minus, square root of 4 is 2. But we need to find the excluded value, so we can't stop there. This is just called factoring. We need to find the excluded value, so we set each one equal to 0 to find out what would make that denominator 0. So if a times b equals 0, either a is 0 or b is 0. Solve each of these, and I get x cannot equal negative 2. And if you don't understand why it can't, put negative 2 in. Negative 2 times negative 2 is positive 4. 4 minus 4 is 0. I can't have 0 in the denominator. That's why it's an excluded value. The other excluded value is 2. X cannot equal 2. Same reason, 2 times 2 is 4, minus 4. So now go on a number line. Plot those 2 points and put circles at those 2 points because those numbers need to be thrown out. Everything else on the number line will work, but those 2 numbers need to be thrown out. So let's put our negative infinity and our positive infinity on the graph. So we'll start with interval notation in the next video.